Good morning, student. This is Anjali, Assistant Professor, Department of CSE, AIML, IARE, Hyderabad. Today we are discussing on the question bank, which is related to basic mathematics and probability for data science. Students, you are very aware about the mathematics and the probability. Mathematics is just will contain some digits, some graphs, visualizations, and probability we can say that the possibilities of getting particular event, particular output. So let's see what are the questions we are covering. We'll cover one by one. First question is that let A and B be events on the same sample space with P of A equal to 0.6 and P of B is equal to 0.7. Can these two events be disjoint? Here we have to find out these events can be joint or disjoint. So first we will see step by step. Definitely this event can't be disjoint. Why? We will see. Actually there are two events. There are two events on the sample space for the disjoint, and the sum of the probabilities of them should be equal to 1. Definitely, for disjoint, your probability, sum of the probability should be 1. Like for P of M plus P of N is equal to, it should be equal to 1. But here, in this case, probability of occurrence event A, there are two events, event A and event B. Both events have the probabilities. Event A have probabilities like a 0.6 and event B probability have 0.7. But when we are adding these events like 0.6 plus 0.7, we are getting the 1.3. So that means this probability is greater than 1. 1.3 is greater than 1. So that's why we can't say that these two events are disjoint. For disjoint, the probability should be equal to 1. Now next one is that Alice has 2 kids and one of them is a girl. What is the probability that other child is also girl? Here you can assume that there are an equal number of males and females in the world. Now, family of 2 children with being a girl. This is given. In family, there are 2 children, but there is definitely 1 girl. Now, we have to find out the another child is also girl. Probability for that the another child is also girl. So, all possible outcomes can be here. 1 girl is definitely girl. 1 girl is definitely girl boy, girl, या फिर और boy girl. So these are your sample space. More than these things, there are no any possibilities. So we can say here we have n of s is equal to 3. These are the number of space. So only favorable outcome for both children to be a girl is only 1. There is only 1 chance. So definitely our probability is 1 by 3. We don't know the second child is girl or boy. So we can say that the girl is only the possibilities where we are getting 1 by 3 probability. Now next one is a fair 6-sided die is rolled 6 times. Now what is the probability of getting all outcomes as unique? So here the sample space of all possible outcomes has 6 power 6 outcomes. That means as each of the 6 rows has 6 possible results. So favorable outcomes are the 6 permutations of 1, 2, 3, 4, 5, 6. So here P of 6 different values. P of 6 different values, that means 6 6 permutation 6 6, 5 permutation 6 5, 4 permutation 6 4, like that, and at last we will get the 5 by 324. Now next one is that find the vector joining the points P of 2 3 0 and Q -1 -2 -4 directed from P to Q. That means we have two vectors, vector P and vector Q. Vector P has points 2, 3, 0 and vector Q has points -1, -2, -4. Now we have to find out the vector PQ. Vector PQ, that means -1, -2i plus -2, -3j plus -4, -0k. Then after that you have to solve -3i, -5j, -4k. So here your vector joining is that PQ bar is equal to -3i, -5j, -4k. Next question is, how would you explain a confidence interval to a non-technical audience? Now here you have to explain the confidence interval to the non-technical public, non-technical audience. So first rule of thumb is that to avoid using jargon or technical terms that may confuse your audience. Here definitely whenever we are communicating with the audience, at that time you have to avoid the technical terms, because they don't know, your audience don't know the technical terms. So at that time you have to avoid the using of the technical terms. So because of that your audience will not get the confused. So then instead of saying confidence interval, you can say the range of possible values or margin of error. If you will say to confidence interval to the audience, so definitely they don't have any idea about the confidence interval. But if you will say the range of possible values, or you can say margin of the error, so definitely they can get the idea. They will strike the what you are saying. Then next one, instead of saying 95% confidence interval, you can say very likely or high confidence. You should avoid the saying of 95% of confidence interval. So don't use the 95% confidence interval. Just use these terms, very likely or high confidence. So these three terms you can use. That means when you will use these things, your audience will not get the confused, and they can understand. They will got your point, what you want to say. There are three rules. First, you have to avoid the using of the technical terms in front of your audience. Then you can use the instead of confidence interval, like a range of the possible values, margin of the errors, and another thing is that instead of you can use the 95% confidence interval, you can use the very likely and high confidence. Next one is that where set theory is used in a real life. Set means just a group. We can say that the set theory is extensively in mathematics, and we know that we are using the set theory in various fields, in various terms. Like it is used in the statistic, like probability, and many notions probability are drawn from set theory's consequences. So set theory is a very important term because it serves the foundation of the rest of the mathematics. It will provide some axioms which are related to the mathematics, which will help to build the mathematics term. Then again, applied to business operations, set theory can assist in planning and some operations also. And every element which are related to business can be grouped into at least one, such as accounting, managing operations, then production and sales. So within those sets are other sets. So this we can use the set theory in our real life. Now next one is explain the statistical background behind power. Actually, there are five primary factors which will affect the power of the statistical test. Those are level, difference between group means, variability among the subjects, and the sample size. Four factor means level, means, difference between the group means, then variability among the subject, and the sample size. Then after that, the higher statistical power of the test, the lower risk making type 2 error, and power is generally set at 80%. That means what they are saying, if there are two effects to be found in 100 different studies with 80% power, only 80 out of 100 statistical tests will actually detect them. Now, how matrix is used in artificial intelligence? Matrix means just we can say it's an array. So matrix is a rectangular array of the numbers, and those numbers contained within the square bracket like A, B, C, D, E, F, G, H, I. This is your matrix. So this value we are storing in the square bracket, and in other words we can say it's just a two-dimensional array made up of rows and the columns. So numbers contained in matrix or matrix element can be data from machine learning problems such as feature values. So matrices are just a fundamental concept which is related to total artificial intelligence, especially when we are working in the neural network and majority of subfields of the machine learning. Now next one is a fair six-sided die is rolled twice. Now what is the probability of getting 2 on first roll and not getting 4 on the second roll? Now here we are rolling a six-sided die 2 times, and we have to find out the probability of getting 2 on first roll and not getting 4 on the second roll. So there are two events which are totally independent. The first roll of the die is independent of the second roll. Therefore, the probabilities can be, we can directly multiply. So, P of getting first 2, that will be 1 by 6. And no second 4, that means 5 by 6. What we have to find out, getting 2 on the first roll and not getting 4 on the second roll. We know that we will get this sample space. N of S is equal to 6. Getting 2, that means it's repeating only once. So definitely our probability will be 1 by 6. So the second one is that probability of not getting 4. Not getting 4 means remaining you are getting. Remaining value, we are not getting this one, but this 5 value, there are chances to get this 5 values. So definitely that probability will be 5 by 6. And after that, we have to multiply 1 by 6 into 5 by 6. That is 5 by 36. So this is your total probability. Now next one is that how can you calculate accuracy using confusion matrix? Actually, the formula for accuracy is number of correct prediction which are divided by the total number of the prediction. So the formula above adds counts along the diagonal of the confusion matrix, which are all the correct predictions, and divides it by number of the predictions and the sum of all counts in confusion matrix. Now, when you have to calculate the accuracy, so there is a one formula TP plus Tn divided by Tp plus Tn plus Fp plus Fn. So this is the formula for finding out the accuracy using the confusion matrix. So misclassification rate, it tells you what fraction of the prediction were incorrect, and it is also known as the classification error. And you can calculate it using Fp plus Fn divided by Tp plus Tn plus Fp plus Fn, or you can say 1 minus accuracy. Now next one is explain the applications of probability and probability in detail. Probability means just we can say the possibilities of getting events or outcomes. So first probability is that sports outcome. Just we can say that it's just we have explained here just examples. So coaches have probability to decide best possible strategy to pursue in a game. Now here coaches have to decide which strategy they have to use. When particular batter goes up to bat in baseball game, the players and coach can look up the player's specific batting average to deduce how that player will perform. Here coach have to decide. Then the coach can then plan their approach accordingly. Then next one is that card games and the other game of the chance. The card game like Rummy uses probability as well as the permutations and the combinations for guesstimate the kind of the cards, which kind of the cards are available on the table. So poker odds are another great application which is related to our real life. Generally, players use the probability for estimating their chances of getting the good hand, bad hand, and whether they should bet more or simply fold their hands. Next one is that insurance. The higher the likelihood of you running into an accident, the higher the premium you have to pay. So teenage boys end up paying a whole lot more on car insurance than other people. So this is one way insurance companies do business, by breaking down complex real life situations into numbers so they can help the most number of people and penalize people that are high risk. So the insurance company make use of the probability in the real life world for making the money. Now next one is the traffic signals. So what's the average of amount of time you will spend waiting in the traffic? Actually, did you know traffic signals work on probability as well? So roads with high traffic have higher waiting times because of the traffic signal. Definitely we have to wait for so much time. So it's programmed into the signal. Why? Because the people that create and set up these signals understand the average number of people that need to cross the roads, understand the average number of vehicles in an area. So whenever you can understand, here you can understand the flow of the traffic in city, and even you can estimate the number of green lights. So you will end up with you take pen and paper in hand and write down all the possibilities. So there are so many possibilities with using of the traffic signals. Next one is that medical diagnosis. The chances of you having an exotic serious disease if you have a cough is very low when compared to coughing. But because you have simple throat irritation, simple infection, something else really mundane. So doctors have to understand false positive and false negatives extensively if they want to diagnose patient. Definitely they have to guess, they have to find out what is happened. So they deal with the dozens and if not hundreds of the patients a day. So doctors use all kind of mathematical techniques in their daily life so they can treat people efficiently. And this is one of the more useful probability example which is we are using in real life, so it can save the people's life when done correctly. Next one is election results. The political pundits are everywhere, and once the election results draw near, you can be sure every news channel in your country will be filled with buzz about the winner. So, election officials use historical data to understand how a region voted previously to understand who they will vote for this time. So that means those are also just a guessing, prediction. Then shopping recommendation. If you wonder why you have Amazon recommend certain products to buy after you finish purchasing something else, because business understand customer behavior actually, so they understand you so well, in fact, that they can guess your next purchases based on what you have previously bought. So if you are shopping for shopping clothes, for example, there is very obvious chance that you will buy baby slippers, diapers about 9 months later. So it's the this is not just a rocket science, but probability can help you understand shopping habits of the people in the present and predict their shopping habits in the future as a result. Now we will move to next question. What parts of the linear algebra are used in machine learning? So in fact, linear algebra has several foundational use cases in the machine learning algorithm machine learning, which are including data representation, dimensionality reduction, then vector embedding. So machine learning has just a strong connection with the mathematics, and each machine learning algorithm is totally based on the mathematics, and it will help it also, with the help of the mathematics, you can choose correct algorithm, which algorithm you have to use for particular situation. And again, you can use the correct algorithm by considering the training time, complexity, and the number of features. So here, linear algebra, we can say that it's an essential field for the mathematics, which is defining the study of the vectors, matrices, planes, mapping, lines required for the linear transformation. Now, next question is that explain the frequentist approach. So, frequentist statistic is a type of statistical inference. It will draw the conclusion related to sample data by emphasizing some frequency or proportion of the data. And so for that, we can say that it is the frequentist inference. So this is alternative name for the frequentist approach. The frequentism is just a study of the probabilities with the assumption, prediction, they can result that results occur with the given frequency over the some period of the time, or we can say with the repeating of the sampling. So as such, some frequentist analysis must be formulated with the consideration to be assumptions of the problem frequentism attempts to analyze. So frequentist statistic, generally there is main advantage is that it is user friendliness and they are easy to use and easy to interpret. So this is why they are standard across many disciplines and they only give you point estimate rather than the probabilities, and they are totally dependent on the number of times the study is conducted. Now explain the filter method with its flowchart. So filter methods are totally used for the pre-processing step. The selection of the feature is independent of machine learning algorithm. So instead, features are selected on the basis of their scores in various statistical tests for other correlation with outcome variable. So the correlation is subjective term here. For basic guidance, you can refer the following table like feature response, continuous categorical, continuous Pearson correlation, ANOVA, categorical, LDA, chi-square. So we'll see one by one Pearson correlation. Actually, it is used as a measure of qualifying their linear dependence between two continuous variables like x and y, and that value will vary from the -1 to 1. So we can say the Pearson correlation is that rho of xy is equal to covariance xy sigma x sigma y. Then LDA, linear discriminant analysis, which is used for finding the linear combination of the features that characterize or separate two or more classes or levels, we can say the categorical variable. Then next one is that ANOVA. ANOVA stands for analysis of variance, which is similar to LDA except for the fact that is operated using one or more categorical independent features or one continuous dependent feature. So it provides the statistical test of whether means of the several groups are equal or not. Then chi-square, it is again statistical test which is applied to groups of the categorical features for evaluating the likelihood of the correlation and association between the frequency distribution. Then next question is that explain in detail independent and dependent events of the probability. First we will see the dependent event. Dependent events. So dependent events are those which depends upon what happened before. So these events are affected by the outcomes they had already occurred previously. Two or more events that depend on one another, that those are the dependent events. So if one event is by chance changed, then another is likely to differ. So the primary focus when analyzing dependent event is probability. The occurrence of one event exerts an effect on the probability of another event. So there are some examples. Getting into a traffic accident is dependent upon driving or riding in a vehicle. If you park your vehicle illegally, you are more likely to get parking ticket. Then if you must buy lottery ticket to have chance at winning, your odds of winning are increased if you buy more than one ticket. Then committing a serious crime such as breaking into someone's home increase your odds of getting caught and going to jail. So these are dependent event. Then next one, independent event. Event is deemed independent when it is not connected to another event or its probability of happening or conversely of not happening. So that means one event is not depends on the another event. So that is independent event. This is true of event in terms of the probability as well as in our life also. So we can mention it is a true of independent events as well. For example, color of your hair has absolutely no effect on where you work. Two events of having black color, having black hair and working in Allentown are completely independent of one another. There are again some example, taking Uber ride and getting free meal at your favorite restaurant. There is no connection. So this is independent event. Winning a card game and running out of bread. So this is also independent event. Find $1 on the street and buying a lottery ticket. Finding $1 is not dictated by buying a lottery ticket, nor does buying ticket increase your chances of finding $1. So we can say it is an independent event, growing the perfect tomato and owning the cat. There is also no connection. So this is about the independent event. So these are the references. This is all about we have seen in the question bank which is related to mathematics and the probability. You can go through these references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.